Okay, guys, I'm going to show you just a few of these that were on there for homework. Hopefully, if you're struggling with these, this will help. Number one, or the first one I'm going to do, is the simple square root of 36. It's a perfect square, so all we have to do is write what that perfect square is, and that is 6. Now, when you come across one that's like this, which is the second one, square root of 72, it's not a perfect square. So we have to break that apart. And the way we want to break that apart is to say square root of 9 times the square root of 8. We can multiply those two together and get 72, which is equal to square root of 3. That is a perfect square. So that square root of 9 has 3. So that's the perfect square. And then square root of 8 is broke down into 4 and the square root of 2. So we can square root 4, that's 2. And then if we combine all of this, we would have 3 times 2 is 6 and the square root of 2. So 6 square roots of 2 is how you actually say that. Now then, if you do square root of 18, we would break that apart into square root of 9 times the square root of 2. That's 3 times square root of 2. All right. And I think I may have told y'all wrong on this next one. I think somebody already asked me about this one. And I think I may have got it confused with the one below it whenever I checked the answer. So let's look at it. It's the square root of 9x to the third. Okay. We know that 9 is a perfect square. So we're going to pull the 3 out there. And we can pull out an x squared, right? Because that's a, since it's x cubed, we pull out the x squared. So that tells us that it's just x. And then we'd have the square root of x left for that answer. I think whoever I was talking to, I told them not to put the x out front, but we would. Sorry, that was you. Okay, let's move on to the next one. Do it on this next page here. It is 20 square root of 27x squared. So we want to break apart 27. And that's going to be, oh, it just went blank. Square root of 9. And I'm going to go ahead and put my x squared in this radical because it is a perfect square also. And then for the next one, it will just be the square root of 3. Now let's factor it out, pull it out, whatever you want to call it. Square root of 9 is 3. X squared, square root of that is x. Now that would just cancel those out, and then that's 3. So we would have 3x square roots of 3. Now we get into cube roots. Let's do the cube root of 16. That is not a perfect cube, so we're going to break it into something that's going to be a perfect cube, which is 8 times 2. And the cube, I need to put this here. Cube root of 8 is 2, and then we have 2 cube roots of 2. This is, just bring this down. All right, the next one was 3 cube roots of 24a. Okay, and now this one was like that one right here where we had to decide where we put the A. So since it's not going to be a perfect cube, we're not going to put it in with our perfect cube. So this would be 8 times 4. So the cube root of 8 times the cube root of 4A. Not 4, 3. Crazy. 3A. Okay, now we can do that. We have cube root of 8 is 2, and then we just have our immediately that's the cube root of 3. Cube root of 3A. Don't forget, like I'm doing on a lot of these, don't forget if it's a cube root, you have to leave it as in the radical there out front. Okay, now then this is where it kind of gets a little tricky. It's kind of good, yeah, a little tricky. This is 9a squared plus 9b squared. This is the tricky part because it's the addition inside of it. So we really can't do anything to break that apart. But what we can do is we can factor out or pull this out of the radical. What's the square root of 9? Well, that's 3. And that's all we have to do, even though it's on both of the terms. And the reason why that's all we have to do is because when you leave these as 2 terms inside here, you got the sum of 2 squares inside a radical. You know to distribute that to both terms. Okay, so that's just your answer. All right, let's get an example. We have to rationalize the radicals. Well, this one's not it, but this is square root of 25 plus the square root of 45 minus square root of 20. Yeah. Well, this one's fine. We like this one. It's just square root of 25 is 5 plus we're going to have the square root of, let's do 9 plus square root of 5 minus, we break this apart, we will use 4 and 5. So what we would do here is say, since we can break this out, let's go ahead and do that. That'd be 5 plus square root of 9 is 3. Let's go ahead and call that 3 square roots of 5 since we're multiplying. Minus 2 square root of 4 is 2. So and now we can just combine these. Since they're both square roots of 5, we would say 3 minus 2 is 1. So we'd have 5 plus 1 square root of 5. All right, let's go to page 8. Let's do 3 square roots of 3 minus the square root of 3/4 plus the square root of 1/3. Okay, we'll have to do some rationalizing the radicals here. Okay, so we say 3 square roots of 3 minus square root of 3/4. What we're going to break apart is, let's go ahead and write this down. We're going to break this one apart. So we're going to say the square root of 3 over just 2. Notice that 2 in the denominator is not, that is not going to be under the radical. It is by itself because we took it out of the radical by square rooting it. Okay, and here, don't forget that you could square root 1. Okay, so we take it out of the radical, leave it as 1, but then that leaves our 3 as a square root of 3. And we do not like that at all because that is a radical in the denominator. So we got to rationalize that. So let's multiply by square root of 3. And the reason why we do that is because we know that the square root of 3 times the square root of 3 gets rid of our radical. Okay, because that's the square root of 3 squared, and that radical and that square cancels out and leaves you with the square root of 3 over 3. Okay, it just leaves you this 3 here. So now, rewrite all of this. Now, what's our problem here? Let's go back to 3rd grade. Probably may even be 2nd grade, I don't know. Our problem here is we can't add these because we don't have common denominators. We can't combine these terms. So we're going to have to find what is the common denominator. And hopefully you're looking at this and knowing that we can put that over 1. So 1, 2, and 3. Common denominator is going to be 6. So let's try 6. Well, 6 times the numerator is going to be 18 square roots of 3. Almost think of your square roots of 3 as an x. And so you would just multiply by what's in front of it. Minus 2 times 3 gives us our 6. So we got to do the top by 3. And that would just be 3 square roots of 3 over 6. Okay. Now, if you notice that, that's over 2 here. Well, look, this is 3 over 6, which is 1/2. As if this was a 1 out front, that's a 1/2. Okay. Keep going. 3 times 2. So do the top by 2. And you have 2 square roots of 3 over 6. Now we have common denominators and we can combine like terms. Excuse me. 18. So basically just get rid of all of these. Put that over 6. We know that's what's going to be there. Don't worry about those. We're just going to copy all of that over here. Now all you're looking at is your what's out front of your radical. 18 minus 3 is 15. 15 plus 2 is 17. And you would read that as 17 square roots of 3 divided by 6. And if these two could be reduced somehow, so if it had been 18 over 6, that would just simply be 3 square roots of 3, because 18 divided by 6 would have been 3, but it's not here, so we have to leave it as a fraction. Now let's go to the next one. Oh, this one's ugly looking. 3, so it's cube roots of 54 minus cube root of 8 plus 7 cube roots of 1/4. Okay, let me see. We're looking at cube roots of 54. Cube roots of 54. 8 54 divided by 8. That's 6.5, so that won't work. Let's do, let's do this. 27 will work. Let's do, we just do, and when I say 27 will work, I mean 27 times 3 cube roots of 2 minus 3 cube roots of 8 plus 7. Okay, so let's go ahead and do the cube root of, oh, no, we're going to go ahead and cube our 1. So let's see here. We can just call that, since we're going to cube root 1, we can say, so let me just do it like this, over cube root of 4. Now, what we're going to say is 7 times 1, and we're going to move that to the numerator here in a little bit. But I was going to do that, but I wanted to show you why you could do that. So let's start back over here on the left side. Cube root of 27 is 3 times 3 times 3, so that's 3. Cube roots of 2. Remember, this right here is multiplied together. Okay, so you just have 3 cube roots of 2 minus, well, cube root of 8 is 2 plus, let's go ahead and move that to the top. So that's 7 over 3 cube roots of 4. Now we can rationalize that and just say, let me see if that's going to be the best way to do that right now. What if I said, let's break this apart and say 3 cube roots of 2 times 3 cube roots of 2. All over 7. Because now what happens, if I go ahead and say, all right, let's do the cube root of 2, 7 times the cube root of 2. Oh, that is awful. Let me write this over here. Okay. Now what happens is we have 3 roots. We have 3 cube roots, so those all cancel out and just leave you with what's in that radical. Okay, so that would leave you with 7 cube roots of 2 over 2. Okay, so let's do that. 3 cube roots of 2 minus 2 plus our 7 cube roots of 2 over 2. Now, I don't want to do, we could put all those over 2 and do that, but if you want, you can do that on your own. I just showed you in the previous one how to rationalize and do all that stuff. So actually, we don't have to. Just leave it like that. There's no radical in the denominator, so just leave it. All right, number 10, or not number 10, page 10. And we have, scroll up here. We have the cube root of 5/8 plus, and let me make sure you know that all of that's under there, plus the cube root of 40 minus 3, or the cube root of 8/9. All right, so since we already have our 8 over here on the left, let's go ahead and just say 3, or the cube root of 5 over 8 over 2 plus, I know I can do 8 times 5, so let's do that. Okay, and let's keep going here. I can cube root the 8, so let's leave that, but we're going to end up with the cube root of 9 in the denominator, which is exactly what we don't like because it's in the denominator. All right, so let's rewrite all this again. 3 cube roots of 5 over 2 plus, this is going to be 2 right here, so we're going to have 2 cube roots of 5 minus 2 over cube root of 9. So let's do it like just like we did on that previous one. Let's break this up to, I'm just going to work it out over here. So I'm not going to write that yet because I need to work this over here. Let's break this. Let's cancel this and say 3 times cube root of 3. Okay. I didn't cancel it. I just broke it up. And so to get rid of this, we need another one. So let's just multiply the bottom and the top by the cube root of 3. So these all cancel and just leave you with what's in the radical. So then we're going to have 3 for a cube root of 3 over 3. Oh, 2. Don't need to forget that. Okay, 2 cube roots of 3 over 3. And I think we're fine then. We're going to leave it just like that. That's what I'm leaving it with. There you go. All right, now let's get into this next one. It says evaluate x squared minus y squared. Well, there's a difference of 2 squares, I know that. When x is equal to 33. Oh, that's not right. Okay, and y equals 15. All right, so all that means is we just have to plug in. This is just a simple simple substitution problem. So it's starting out here. So we'd say the square root of 33 squared minus 15 squared. Now remember, we can't pull those out because it's a arithmetic problem. It's an addition or subtraction. If that was a multiplication, and we could figure all that out and work it out. But we don't even have to do that on this one because we know 33, oh, we don't know, but we can figure it out. 33 squared is, this is equal to the square root of 33 squared is 1089 minus, I used to know 15 squared, I think it's 625, 225, I mean, 225. I always think it's 625 for some reason. Anyway, so if I did that, that'd be 1089 minus 225. That is equal to, I'll write it over here, square root of 864. And I'm going to rewrite it over here, 864. And we need to figure that out. Since this is a big number, let's start with 10 won't work, or 10 I mean 9. Will 9 work? 864 divided by 9. That'll be 96. 96. That's divisible by 3. So it should be 864 should be divisible by 12. It is. So let's try 864 minus, not minus, but divided by 144. Perfect. And that's as far as we're going to be able to go. So let's call this the square root of 144 times the square root of 6. So this is going to be 12 square roots of 6. The square root of 144 is 12. All right. Let's go on that one. Man, I'm eating up a lot of whiteboard on this one. Okay, so we have the sum of two squares here. Square root of x squared plus y squared. And x is equal to 20, and y is equal to 10. Let's plug those in. Hopefully y'all are okay with me just saying 20 squared is 400 plus 10 squared is 100. So that's the square root of 500. Ugh. What is that going to do? I guess the easiest thing to do would be square root of 100 times the square root of 5, because that's 500 there. And this would be 10 square roots of 5, because the square root of 100 is 10. Yep, that's all we can do there. Right, number, I don't know what it is for y'all. Let's just keep going. Square root of 3 times the square root of 7 minus square root of 3. What are they doing here? Hey, the first thing that clicked in my head was if I distribute this, I'm gonna have the square root of 3 times the square root of 3 right here. So that's just gonna leave me with 3. So let's just do distributive property. Square root of 3 times the square root of 7. Now we can do this. Don't forget it. We can call that 21 since we're multiplying. Okay, so the square root of 21. And like I said, when we have the square root of 3 times the square root of 3, that's just minus the square root of 3 squared. And those are going to cancel, which leaves you with 20 square root of 21 minus what's in the radical. So there you go. Simple. All right, the next one is 3 plus the square root of 2 squared. Now, let's see. Oh yeah, this one's gonna be neat. That's gonna be cool. All right, let's do this. 3 plus the square root of 2 times 3 plus the square root of 2. If we full first, outer, inner, last, the first is going to be 9. Outer and inner is going to add up to be 6 square roots of 2. And then what happens when you do square root of 2 plus square root of 2? That's just going to leave you with 2, right? So we would end up with 11 plus 6 square roots of 2 when we combine these terms. Yep, so there's our answer. All right. Okay, this next one is 2 plus the square root of 3 times 2 minus the square root of 3. Hopefully right now you should all be saying, hey, that's conjugates, that's conjugates. And you know what conjugates produce? Those produce, or those are factors of the difference of two squares, right? So let's see how that works out here. You should know that you don't have to do the outer and inner part if we were to full it, because with conjugates, outer and inner cancel. That's the beauty of conjugates. Those cancel because of this plus and this minus. I completely did that backwards because the minus and the plus, y'all know what I'm saying. So let's just do the first and the last. 2 times 2 is 4. The last is 3 squared, or the square root of 3 times the square root of 3. So that's just going to be minus 1. Remember, it's I'm sorry, not 1, 3. Because the conjugates are the difference of two squares. So there you are. And now you have 1. So the answer is actually 1. 4 minus 3 is 1. That's the beauty of the difference of two squares. Very same thing on this next one. 2 plus 2 square roots of 5 times 2 minus 2 square roots of 5. Same thing, conjugates. You should see that right off the bat. Now let's see how this one's going to work out. Okay. So let's go ahead and do 2 times 2 is 4. 2 square roots of 5 times 2 square roots of 5. Now let's look at that. 2 square roots of 5 times 2 square roots of 5. Now we know that it's going to be subtracting that because conjugates are the difference of two squares. So what is the two squares in this case? Well, that would be 2 times 2 is 4. And then remember, these cancel and just leave you with what's inside that. So it'll be, not square root of 5, but times 5. Because that's 2 times the square root of 5 times 2 times the square root of 5. So now we have 4 times 5 because the square roots cancel. So when you do that, you would have minus 20. Well, what's 4 minus 20? It's going to equal a negative 16. All right, let's go to the next one. Same thing. Square root of 7 minus 3. Conjugate is square root of 7 plus 3. Nothing different. We don't have to do the first outer and inner last because we know those outer and inner are going to cancel. Square root of 7 times the square root of 7 is 7 minus, because we know it is minus because of the difference of two squares, and we know because negative 3 times 3 is going to be a negative 9, which equals a negative 2. See, this is what I'm talking about. If y'all learn these, they are super simple. Okay, you should be able to do, let's see here, where do I need to skip down to? Trying to see here, because those are all the same thing. Remember, those last 3 or 4 is going to be tricky. Don't have to do them if you don't want to. I think I put them on there though. I can't remember. All right, let's skip down to one that looks. Okay, let's do this one. I'm gonna go ahead and go to a new screen here. Let's do the one that is the square root of 21 minus the square root of 3 divided by the square root of 3. Okay. So what that is saying is, what would happen if we divided that first binomial by 3? Okay. I'm going to show you, let's do long division. I can do it, long division. That's going to be crazy, but I can do it. Not the way I would do it, but I'm going to show you how I would do it. How do you get the square root of 3 to be the square root of 21? The square root of 7. Now, if I do that, square root of 21, negate that, that cancels. Leaves you with a negative square root of 3. How do I get a square root of 3 to be a negative square root of 3? I subtract 1. You'll probably never see another teacher divide radicals like that. But there you go. That is equal to the square root of 7 minus 1. Now, I'm going to go back and do it the way I would do it. Square root of 21 I don't know what the problem was, minus the square root of 3 divided by square root of 3. I would simply move that over here and put it in the denominator, okay? But you say, Mr. Anderson, why are you doing that? That's crazy. You can't do that. Well, think of it like this. I could break this apart and say square root of 20, square root of 21 as the square root of 7 times the square root of 3 minus 3, square root of 3. Put that all over the square root of 3. Just cancel, leaves you with 1. So that would leave you with this, and then this would be negative 1, which leaves you with the square root of 7 minus 1. That's one way to do it. Okay. The other way to do it is just to think about what does it mean to divide by the square root of 3. That means it's a factor, right? So if I just said, what does it mean to factor out the 3, the square root of 3 from the square root of 21 minus 3, well, that's going to be the square root of 7 minus 1 if I just factored that out. There are several different ways, whichever one you like the best, go for it. Let's see. Well, this one's probably going to be a little bit harder. Let's try that. Square root of 5 plus 4 divided by square root of 5 plus 1. Okay, and you have that in parentheses to know that that's all divided by. Okay, and actually this is all divided by. Okay, so I don't like that. I don't like the way that's written, so I'm going to rewrite it. I'm going to say the square root of 5 plus 4 over the square root of 5 plus 1. Okay, when I do that, I know, and remember, we can't just, that's one term written as a binomial. So I can't have that radical in the denominator. So I'm just going to multiply by the square root of 5 plus 1, the square root of 5 plus 1, which means my denominator is now going to be these radicals cancel, leaving me 5. Okay, what's ooh, let's not do that either. Let's not. Only thing we want to change here. Okay, I keep forgetting to do this to help it cancel better. We want to do this by the conjugate. We want to make conjugates of the denominator. That way we don't have to worry about the outer and inner part. That's the beauty of it. We'd have 5, and it's the difference of 2 squares. Well, what's 1 squared? 1. So we have these cancel and just simply leave us with what's on the inside. And then we would say 1 times 1 is 1. So it's minus 1. Now with the top part, that's not as simple because we don't have conjugates. We do have the plus and the minus, but we don't actually have conjugates. It works out well for the first term. So we're going to do first. That's going to leave us with 5, right? Square root of 5 times square root of 5 is just 5. The square roots cancel. But we still got to do all the other. Now I know that my last one's going to be minus 4 if I do the last. Now let's do the outer and the inner. So if we do outer, that's going to be a negative square root of 5. If we do the inner, that's going to be, what is that? 4 plus 4 square roots of 5. Okay. Now we would have combined like terms. Let's start with the 5 and the 4. That's going to be 1. Negative square root of 5 plus 4 square roots of 5 would be a plus 3 square roots of 5 all over 4. Now, what they're going to say is, since you have 2 numbers right here, this 1, notice that all of this is over the 4. So you can pull that out and say 1/4, and then so what they would say, that's 1/4 plus 3 square roots of 5 over 4. And it's goofy looking. I don't like that. So since I know there's a 4th here and 4ths here, I'm going to factor out a 4th and say this 1/4 right here divided by 1/4 is 1. And then I can just say plus 3 square roots of 5. When I divide 3 square roots of 5 divided by 4 divided by 1/4. Same thing as multiplying by the reciprocal, right? Did I say that right? Multiplying by the reciprocal. Multiplicative inverse. Yeah, that's right. Okay. Now it's a little bit tougher. 19 looks to be about the same. Or 19, page 19. I don't know what the number is in your. Yeah, I think that should be good. Hopefully that'll help y'all get through your homework. Sorry if it's been noisy. I'm at home. We'll see you guys Monday. Have a good weekend. Bye.